All right. Do you see my full screen? I hope so.
Yeah. That's perfect. Yes.
Yeah, perfect. I'll start my timer to have a little bit of an overview, or you can tell me when the time is overdue anyway. So
yeah, so you have 20 minutes, but you can go further, and then we tell you if it's too late.
All right. Thank you. So yeah, my name is Didier Schmitt. I'm working for the European Space Agency, and in particular, indeed, I'm in charge of the coordination of the exploration programs, so both for robotic and human exploration. And I'm also in charge of the future strategy of the program. So what I will be doing is I will show you a little bit about, what we are, first of all, what we're doing, and then of course also what we intend to do in the next decade, meaning after 2030, because obviously we are doing long-term planning, and for us long-term planning is relatively straightforward. We have to plan at least 20 years ahead in our programs, because space exploration takes quite a lot of time. Now, for those who don't know ESA is the European Space Agency, and we're actually active in a lot of areas. I think we are probably the most broad space agency worldwide. We do launchers, we do Earth observation, telecommunication, navigation with the Galileo program. We do space science and also space safety, and exploration in particular, so robotic and human.
Sorry to stop you. I think this is a previs of the slideshow, so there should be an option to put it in full screen.
Okay. Let me see whether is that better?
Yes.
Okay.
Perfect.
Sorry. Yeah.
Good.
Put things in context before talking about the European Space Agency's activities in exploration. You may have followed, because it's pretty often in the news, what happens in China and in the US in space exploration. Let's start with China. It's a newcomer, but very fast and very active partner in the space exploration programs. You have probably heard, because it made the news in end of 2018, China landed a robotic mission on the far side of the moon, which is the first. They recently, early this year, they made a sample return mission from the moon, and they're planning a series of what they call the Chang'e series of landers, where they will bring back samples from the south pole of the moon this time, and regularly have missions planned until the end of this decade. So a very active program on robotic space exploration. Now, it is very obvious from what we know and the scarce announcements which have been done by China that they indeed want to land Chinese on the moon. And this is why they have chosen recently to develop a deep space exploration rocket, so a very heavy launcher, which is more or less equivalent to the Space Launch System from NASA, which could carry up to 40 or even 50 tons around the moon, which means that they will have the capability to land humans on the moon by the end of the decade in principle, if everything works well. So that is very clear that China wants to compete and will compete with the US. So you're probably more familiar with the programs in the US. You may have heard about the Space Launch System, the SLS, and the Orion capsule, which will go to the moon and around the moon, which will bring 4 astronauts around the moon, and eventually in the Artemis program, landing on the moon, hopefully by the mid of this decade. This is the NASA, purely the NASA program. There are also commercial programs. There are both for the robotic part of the moon exploration, but they're also part, in part, for human access. And you have heard, of course, about the SpaceX program with the Dragon crew, which goes to the docks with the ISS. And more recently, a very surprising contract given by NASA to SpaceX for the Starship, which is, in principle, if everything works as planned, a really big revolution, because the Starship is equivalent in volume to the International Space Station, so 1,000 cubic meters, and it could land on the moon with a maximum payload of nearly up to 100 tons. So it's a massive disruption if this goes ahead and works. So let's see what Europe is doing in this context. I have just spoken about the Orion capsule, which will bring 4 astronauts around the moon. We are actually a major partner in this program of NASA, because if you look at the circle here, the green circle, the propulsion element, the life support element, and which gives also the electrical power to the Orion capsule, this is made in Europe. So that is very, very important from a strategic point of view. It is the first time in the US history, in the space exploration history, that NASA depends fully on a foreign system in what we call the critical path, which means that it does provide a critical system to bring any American or international crew later on to the moon. So this is to be noted. So each time the SLS rocket will launch the Orion capsule, this capsule will have a propulsion system and a life support system made in Europe. So that is a first. So we have currently contracts in place. You see even a picture of the first Orion system, which is now docked to the ESM, to the European Service Module. And if everything goes well, this would be launched at the end of the year for a first test flight without crew at the first place, and then end of next year with a crew on board, a crew of 4, which will go around the moon. Our second significant participation is in the Gateway. You may have heard as well about the Gateway. So the Gateway is a space station which will orbit around the moon. It's not a circular orbit. It's a very, very long elliptical orbit. So to do the whole elliptic, so up to 70,000 kilometers and then closer to less than 1,000 kilometers, it will take a week for the crew to do each of these orbits. Here you see the full Gateway layout. The Gateway is there to have a landing system docked to it and then to land on the moon and to come back. The core structure of this Gateway is essentially a habitation module and some other logistics to have, so attitude control and so on. What is very important to notice here is that half of the space stations around the moon will be built in Europe. So again, here we are fully partnered with NASA to build this Gateway, and I will get a little bit in more details about what is our contribution. So the core contribution of ESA for the Gateway is what we call the IHAB, which is the International Habitation Module. So this module will host the 4 astronauts, which will come to the Gateway with the Orion capsule, as I just mentioned. It will dock to it, and they will be able to live there for a couple of weeks, up to 6 weeks if needed, depending on the missions, which will happen on the surface of the moon. And then obviously the crew will come back with the Orion module and landing on Earth safely. Second element of the Gateway is what we call Esprit. It's about name, it does provide, it will provide, the launch is foreseen in 2027, a refueling capability and telecommunications, and also a viewing capability, which is new. So you see here on this virtual drawing that we will provide the window, so to say, of the space station. Otherwise, for the habitation module, because of its structure, will not be able to host any windows. We have signed the contracts for these modules, the IHAB and this Esprit module. You see here the logo of Thales Alenia Space. So for the IHAB, it is TAS, so Thales Alenia Space Italy. And for this Esprit module, it will be Thales Alenia Space France from Cannes, who has gotten the contract. So these developments are fully in place, and they will be launched from the US with an SLS mission. Now, these are programs which have been decided, which are funded. Now there are new elements in our Moon program. One is, and we will talk a little bit more later on, is to have more identity and more autonomy. Let's face it, for the space station and for the gateway, we are, of course, strong partners, but we have not decided, so to say, on the fate of these activities. What we want to do is to initiate a new program, which we are studying currently in quite some detail technically. And this is a European lunar lander, so a large logistic lander. And this lander will be able to launch with the Ariane 6, which is supposed to be hopefully have a maiden launch early next year. And the full capacity of this Ariane 6 will be used, namely to put in orbit around the moon 8.5 tons, and landing on the surface about 1.5 tons of payloads and instruments. By doing this this program on the landing system, we hope to be able to interest NASA enough to have, for example, logistic flights very close to the Artemis landings, so that we can provide logistics and cargo and scientific instrumentations and so on, so that we can then make a barter. This is usually what we do with the US. We provide elements, and in return we have crew flights. And here the official target now from now on is to negotiate with NASA to have a European walking on the moon by the end of this decade. And this we want to achieve by providing this lander. Of course, there are other programs than the moon, and we obviously look into currently the post-space station program and the post-Mars sample return missions as well, but that's not the topic of today. So here are a few models of what we're currently studying for this large logistic lander. There are several configurations possible depending on the type of missions. It will not be one mission only. We hope to have, we are planning to have the first mission landed in 2029, so before indeed the end of this decade. And then we are planning to have a flight every 2.5 years roughly. So it could be logistics, it could be purely science, it could be a combination of those missions. And essentially the most important part, of course, to explore from now on is the south pole of the moon. And this is where we are targeting our landings. So, of course, the moon exploration program is a little bit more complicated and more, let's say, there is a panoply of activities that we're currently planning for the next decade. What I have shown you here are things which are underway and which would happen by the end of this decade. Now we are obviously also preparing the activities for the next decade. So I have spoken about the gateway. We have already secured, by the participation in the gateway, 3 astronaut flights, European astronaut flights on board of the gateway. So starting as early as 2025. So that is already something which is done. I have mentioned the service module, which will propel, so to say, the Orion capsule to the gateway. And by providing these elements, we have made the bar to have 3 astronauts, at least around at the beginning of the assembly of the gateway. There are other elements we are currently working on. Is a complete set of telecommunication capabilities around the moon, which we could also provide to international partners. And as mentioned, for example, here the Polar Explorer could be a European purely scientific mission on the south pole of the moon by the end of the decade, or most probably early next decade. What is very important once you are on the moon? So here we talked about going around the moon, the telecommunications part, a robotic lander. But obviously, if you plan human landings, which is something we will do with the US, we have to be mobile on the moon. You know, just landing on a spot like the Apollo program is not enough. We are now looking into options to have a very long-range mobility systems, and for this, obviously, that needs to be pressurized systems. You know, if you want to travel 200, 300 or more kilometers, you have to spend days in this rover, and that means that it has to be pressurized, where you can of course undo your EVA suit and go outside with an EVA suit again. Most importantly, when you are on the moon for a longer duration, which means this long duration surface mobility, you will need energy. One of the reasons is very simple. You know that the moon nights are 14 days. And during these 14 days of nights, you experience about 170 degrees, minus 170 degrees Celsius, which means that you need energy. So we are even now looking into radioisotope energy heating systems, or even producing electricity with radioisotopes. And once you have energy, you can go to the next step, which means utilizing in situ resources like, we have discovered water on the moon. So if you want to extract it, to electrolyze it, to have hydrogen and oxygen as propulsion systems. So this is what you need to do. You need to have decent power. And then obviously the bigger picture, if you want to develop what we call a kind of cislunar economy, you have to have the capabilities to go to the moon and to come back to the moon. So you have to have cislunar access, and we're also studying capabilities to go to the moon and come back. And at the end of the day, obviously, whatever we learn and test to go to the moon and on the surface of the moon will help us to prepare the next big leap, which is travel to Mars with a human landing on Mars. That we foresee, of course, no earlier than 2040, but still we have to do whatever we can to use the moon to go towards this objective. Now, this is more or less the strategy we're working on. I think you are much too young to know that or to have experienced the Space Lab programs. I was lucky enough to work quite a lot at Cape Canaveral, and I had several experiments on the Space Lab programs in the 90s. So Europe participated in the shuttle program of the US by providing the space laboratory inside the payload bay of the shuttle. So that was really the first opening and the first foot in the door of Europe into the human space program, which allowed us to have several astronauts on these type of missions. More recently, since about 20 years, we are a contributor to the International Space Station. Of course, our contribution is not very significant. It's about 8% of the total resources of the US part of the space station. But still, it has enabled us to contribute, for example, the Columbus laboratory and the automated transfer vehicle, the ATV, where we had 5 flights to the International Space Station with a really, at that time, the most advanced cargo resupply missions ever done to the ISS. So this is for the low Earth orbit. Of course, we want to continue being present in low Earth orbit, and we're currently preparing the next steps for this. Maybe in a participation of a commercial activity for a small space station around the Earth, so at about the altitude of the current space station. So we spoke about the moon programs, the Orion and the service module, the gateway participation. I mentioned the European Large Lunar Lander, and obviously we want to have Europeans on the moon, and this is why we are engaged in working with NASA to have the right arrangements to do so. For Mars, you have maybe heard about the ExoMars mission. The first mission is in orbit since 2016. And we are now committed to land on Mars with a significant rover, which will hopefully participate in the detection of life on Mars by the end of next year, so for the launch, and then of course landing the year after in 2023. We have also a very significant program together with NASA to bring back samples from Mars, and there also we are a strong partner because we will provide the surface rover, which will collect the samples from the current Perseverance mission, and we will also provide the Earth Return Orbiter, which will collect the samples in orbit and bring them back to Earth. This is still for this decade and early next decade, and then we foresee for the 2030s and even 40s to even have a stronger program in Mars exploration, namely robotic missions, obviously landing significant payloads, so much larger than what we are planning now for these rovers, to prepare, of course, the next step, the big leap, which will be landing humans on Mars. And we are trying to position ourselves, and we will do whatever we can to position ourselves to have already on the first mission to Mars, to have a European on board. But obviously to do this, we have to be a strong partner and to provide the right and the adequate systems to be able to do the right partners, obviously with NASA, who would lead these kind of activities. So to finish this presentation, I would like to emphasize one figure. We have launched recently, as you know, a contest to recruit 4 to 6 professional astronauts at ESA, but also up to 20 reserve astronauts, and even 1 or 2 para-astronauts, which are candidate astronauts who have some physical disabilities. So that is a parallel project that we're currently initiating. This figure is very important because 22,000 applicants is well beyond whatever we expected. In 2008, we had 8,000 candidates for the last selection, and this time nearly 3 times more. It really shows that the young generation, and you're part of that, is really interested in space exploration and obviously the human part of the exploration program. So that is a very nice and significant message for our decision makers. When you talk with people, you know, from the finance ministries and others, for them it's always a nice to have, you know, to have space exploration. But we want to show that it's more than a nice to have. It is something really essential from a political, from a strategy point of view, from a technological point of view, from a benefits point of view. be it for the economy or for international cooperation. So we think that this figure is really something very interesting to put in front of decision makers, to show them that there is really a strong interest in the current young generation for what we are doing. So I think we're nearly there. I wanted really to show that we are just focusing on the moon today, that we are ready, of course, for the big second stage, to say, of exploration of the moon. After the Apollo mission, what we want to do is to have a permanent presence on the moon, and we want to do this together with the international partners, mostly, of course, the US, and if possible, also others, even with China, if that is a possibility. And obviously, going to the moon is only one step. The further step will be, of course, to have a presence on Mars. A very big difference, you know it, the moon is our satellite. It has no atmosphere. There has been no possibility of past life on the moon. But Mars is very different. It's a sister planet. And there, obviously, we are trying to look for past life and to understand why this planet changed so much compared to the Earth, because they were very alike. Earth and Mars were very alike from 3.8 or 3.7 billion years ago. So I think I have spoken enough, and as it has been planned, I'm available for discussion and questions.